Hello students, welcome to this machine fault diagnosis course. Today's topic is failures. The contents of the presentation is what is machine failure, what are the types of machine failure, the most common causes of machine failure, how can you prevent machine failure. Okay. First we'll see what is failure or what is a failure phenomena. Failure is nothing but termination of the ability of an item to perform a required function. So every component is intended to perform certain function, and if the component terminates its function uh, before the prescribed period, then it is called as uh, failure. A failure is also related to a required function. The function is often specified together with the performance requirement. A failure occurs when function cannot be performed or has a performance that falls outside the performance requirement. So you can term failure when the component is not performing in the range in which it is intended to perform. So that is also failure. Not performing within the range of specification is also a failure. For example, according to performance requirement, the maximum closing time of a shutdown valve shall be no longer than 15 seconds. That means a wall is there, and if you supply electrical voltage to it, then it should close within 15 seconds. But if the wall takes more than 15 seconds to get closed, then we can say that there is a failure. Okay. Now, what is machine failure? So machine failure is any event in which a piece of industrial machinery underperforms, whether entirely or partially, or stop functioning in the way in which it was intended to. The term machine failure can encompass different, differing scenarios and level of severity. So any machine component which is not performing well or partially or fully, then we can call it as machine failure. A failure in this context is not only those critical showstopper issues that halt production entirely, but also includes any loss of usefulness within a machine. The tolerance threshold of machine failure will vary based on the circumstances, since all the systems degrade and lose effectiveness in some form or the other over time. So, machine failure does not lead to production downtime or increase in uh, cost of production, increase in manpower requirement, but it also leads to some catastrophic failures or may lead to some accidents. Okay. So uh, this is certain examples of machine failures, certain disadvantages of machine failures. For our purposes, any malfunction that causes a piece of industrial machinery to underperform its duties, whether entirely or partially, is considered as machine failures. So this is something about machine failures. Now we'll see machine component deterioration. So if any new component is installed in a machine, then how the condition of that component deteriorates over the period of time. So this blue gradient line indicates the condition of the component. On the x-axis, it is the time period. On the y-axis, component condition. So when the time period is 0, that means when the component is newly installed on the machine, then the condition of the machine is good. But as the time progresses, this blue gradient line uh, coming downwards, that means the downward inclination of the gradient line indicates the deterioration of the component. But by taking proper care, by taking corrective actions at regular interval of time, you can extend the period of deterioration. Okay, but if the problems are not attended, then the gradient line will come down very fast, and we can have a machine failure. So as the time progresses, the condition of the gradient line comes down. First, it starts vibrating. It generates vibrations. Then excessive friction. Because of the excessive frictions, the wear and tear or metal particles are coming out into the oil or lubricating oil. Then if it further deteriorates and it starts creating noise, and if it is still not attended, then because of the friction, a lot of heat is generated. So the temperature of the component goes on increasing, and if it is still not attended, then the smoke comes out from the component and the component fails. So this is the machine component deterioration over a period of time. So, and these are the various indicators, or these are the various indications by which we can judge the condition of the component. Initially, the condition, the gradient line, the blue line is more of a horizontal, and its stiffness to coming down is very, very less. But as the time progresses, uh, the gradient line coming downwards exponentially. Okay, the slope of this line becomes steeper and steeper within a very short period of time. Okay, so so that is why the component has to be maintained, has to be checked at a regular period of time, so that we can increase the life of the component. Now, what are the types of machine failures? So basically, there are three types of failures. First is sudden failure, intermittent failure, and gradual failure. Sudden failure are those failures when, without giving any indication, the machine component suddenly fails, and and that is why there is a lot of loss of production time, manpower, material, etc., etc. So sudden failure means without giving any indication, suddenly the breakdown happens. Okay, so that termed it as sudden failure. Intermittent failure means uh, it gives some indication, then some corrective actions are done, then again after a certain period of time, again it gives certain indication of failure, again some corrective actions are taken, and then the component completely fails. So these are intermittent failures. Okay? So some corrective actions are taken because of which uh, the problem suppresses for a short period of time. Again, it appears on the surface. Again, uh, some damage control is done. Again, the problem is suppressed for some few period of time, some period of time, and again the failure occurs. Okay, so that is intermittent failure. Gradual failure means the component uh, actually fails gradually. If the component is gradually failing, that means that we can say a natural process. But how gradual the failure is, that is a point of contention. So naturally, any component which is in operation undergoes wear and tear, and it starts gradual failure. But we can extend the period of component uh, by taking corrective actions. So gradual failure comes in that category. Then we'll see what are the causes of machine failure. So there are uh, broadly we can say that there are four machine failures causes. First is operator error, wrong amount of maintenance, physical wear and tear, reliability, culture failings. So first is operator error. Now every machine has the operating manual, and if the operator is not following the operating manual properly, then the machine is not being operated properly, and because of that the machine fails or the component fails. So this is because of the human negligence, and that is why this such type of failures are termed as operator error. Then second is wrong amount of maintenance. Uh, uh, if the proper maintenance schedule is not being followed, if the component is not properly lubricated uh, after certain frequency, then component fails. So not maintaining a proper maintenance schedule, not lubricating the component properly, not uh, like not tightening the foundation bolts at a regular interval. These are some of the uh, wrong practices of maintenance because of which the failure occurs. Sometimes over maintenance also a cause of failure. For example, if any bearing is there and if we over lubricate it or very frequently we lubricate it, then the proper heat dissipation is not taken place because of the over lubrication, and because of that also heat is generated and the bearing may get seized. So too little maintenance or too frequent maintenance may be sometimes the causes of failure. Then physical wear and tear, okay, because of the excessive friction between the relative bodies which are in the motion, the physical wear and tear occurs, and because of that machine fails. Then next is reliability cultural failing. So reliability cultural failing, I will explain the reliability cultural failing by taking one example. Now imagine that you have a very important meeting in the office, and in the morning you feel slightly dizziness or feverish kind of a thing. So what you will do? You will take any paracetamol or crocin and suppress that fever for that particular day because you have a very important meeting. But that fever still, uh, the fever gets suppressed, but it doesn't go out of from your body. So again next day the fever reappears again. If you have very important meeting, then you again take some paracetamol. That means you are suppressing the problem. In the same way, uh, the production people the production people are also having production goals, and to achieve those production goals, they have to keep the machine on. They doesn't stop the machine for uh, the required maintenance, and because of that, the machine fails. So that such type of failures are called reliability cultural failings. Now, how can we prevent the machine failure? There are multiple strategies you can use to prevent equipment failure, and choosing the right one depend upon the criticality of the machine, the predictability of its failure, and the budget and monitoring infrastructure available. So, uh, machine failure can be prevented uh, by adopting proper maintenance strategies. Like reactive maintenance is the kind of a maintenance which is taking place when the breakdown occurs. Only when the machine fails, then only we react to the problem. So that such type of maintenance is called reactive maintenance. Preventive maintenance means preventive maintenance includes regularly inspecting the machines prior to use, establishing and sticking to a maintenance schedule, regularly replacing components before their average lifespan is over, and anything that tries towards of the failure before it happens. Think of it like changing the oil in your car every few thousand miles. We don't wait until the oil is mucked and has clogged the rest of our equipment. We just preventively maintain it because based on our expectations when the failure would otherwise occur. So anticipating a failure and taking a corrective action is preventive maintenance. And then comes the predictive maintenance. That means by using a high-end instrumentation, we can actually predict the life of the component, the remaining life of a component by using some high-end instrumentation. So that is predictive maintenance. So these are some of the machine failures, their causes, and the preventive measures by which we can uh, reduce the failures.